Good afternoon, ladies and gentlemen. My name is Jan Cherokee, and today I will talk about Energy Twin, machine learning extensions for energy data analysis. Energy Twin is an extension smoothly integrated into a SkySpark, so it has easy to use interface. It interacts with default applications like Sparks or KPIs. There are no external libraries needed, and data are not sent to the cloud or shared anywhere. So all the calculations are done on the edge on your device. Moreover, we focus on measurement and verification adherence, so you can validate the statistical properties of the identified model with respect to different measurement and verifications requirements. There are two Energy Twin extensions, Energy Twin Analytics and Energy Twin Interactive. Let me start with comparison of these two extensions. First of all, Energy Twin Analytics. It was introduced more than 1 year ago, and it was also presented on the last SkyPosium. It uses more detailed model, and it allows us to focus on hourly or even 15 minutes data. Energy Twin Interactive supports standard models like degrees days models or change point models, and it works with aggregated daily, weekly or monthly data. Both extensions do provide easy to use interface. They do have support for measurement and verification requirements validation. They do provide open API, and they have support for setbacks handling. Specifically for Energy Twin Analytics, you have Sparks for anomaly detections, some predefined KPIs, and uncertainty modeling. In case of Energy Twin Interactive, it has automated change point and model type selection using machine learning, and as its name implies, it's more interactive. At this point, I would like to announce that we will provide a time-limited free version of Energy Twin Interactive to SkySpark attendees, so follow the presentation for the details. I will start with Energy Twin Analytics. I will focus just on the usage scenarios. So I will start with monitoring-based commissioning. Using the Energy Twin model, you can easily identify deviation from the expected behavior. It means deviation from the prediction, and it can be reported as a spark, so you can react to such an event immediately. There are various demand response scenarios when Energy Twin prediction can be used. And there are also tailored KPIs that allows you to focus on different problems of buildings, namely of the buildings, for example, the buildings that do have some setback regime, and you can evaluate the whole portfolio and see which of the buildings do have a problem with setback, or they do have some potential for energy savings there. And specifically, Energy Twin could be used also for detailed evaluation of impact of COVID-19. I will demonstrate this on an example of 3 shopping malls in the Czech Republic, and let's have a look. The first shopping mall was able to maintain the same level of energy savings through all the lockdown periods. Only during the loosening in summer 2020, they almost returned to normal regime. We can see similar pattern in case of shopping mall 2, where the total level of energy savings was smaller, but again they were able to maintain almost the same level through all the lockdown periods. However, in case of the shopping mall 3, we can see different levels of energy savings among the different lockdown periods. Let's have a detailed look. In the first lockdown in the spring 2020, there were energy savings like 60%. They saved almost 400 megawatt hours per month. So this is kind of exceptional result. During the summer, they returned almost to normal regime. And if we jump to the spring 2021, yeah, if you would see just this figure, you can say that they were able to achieve nice energy savings. It was like 22 megawatt hours per month. But question should be why they were not able to save the same amount of energy as they did 1 year before. And you have like 160 megawatt hours per month difference in energy savings that they were able to achieve in spring 2020 and in spring 21. So definitely there was some energy savings potential that was not exploited in 21. And now I will focus on Energy Twin Interactive, the newly introduced extension. It's more versatile, it's more interactive, and it works just with the daily, weekly and monthly data. It provides support for 5 change point models and for 3 degrees days models. It also uses machine learning for model identification and model selection. Actually, the same you can do with Energy Twin Interactive, you can do in Excel, and many SkySpark users do this, that they do export the data to Excel or Google Sheet, and they use the trend and trend line in order to identify the model. Here's an example of the relation between the energy consumption and heating degrees days. On the left side you see the chart from Excel, on the right side you see the chart from Energy Twin Interactive. Let's have a closer look and if you compare the equation provided by both tools, they do provide the same results. The same applies to the statistical properties of the model. In case of Excel, you have R square, and the R square parameter is the same in case of Excel and Energy Twin Interactive. So you basically receive the same results, but in case of Energy Twin Interactive, it's much faster than in case of in case of Excel. I will demonstrate this by the online demonstration that will start with installation of Energy Twin Interactive, and then we will identify the model and see the prediction, so you can see by yourself how easy it is to manipulate to use this extension. So first of all, we need to install Energy Twin Interactive. It can be done using the SkySpark user interface, and let's search for Twin. The 3 extensions, and the third one is Energy Twin Interactive. We could select the version, but the latest one is a good choice, so let's go for install. After installation, you need to restart the server. After the server restart, we can go to settings and enable the newly installed application. After doing this, you should see the new icon of Energy Twin Interactive. However, you still do not have a license for that and you cannot use it. So let's go back to host and to licenses. And installation of the license is quite easy. You just click on install and then you select the file with the license and you copy paste the text there, and that's it. Once we have a license, we can start playing with our data. So let's go to ET Interactive and let's create a new model. First of all, we need to select the point. So pick up some office building and the main meter. Then we select the baseline period, the span that will be used for identification of our model. Then we need to select the aggregation. The rule of thumb here is if you have key W, you select sum. If you have key WH, you select last minus first difference. And let's start with monthly data. In this chart, we do have the on x-axis is the outside air temperature in degrees Celsius, while on the y-axis is the daily electrical energy consumption. Each point is 1 month, and the dashed line shows the model that was identified. We can change the type of the model here. So let's say we go for manual setup and we would like to have 2-parameter model, and you immediately see the output of this. Here is the prediction over the whole year, and the same is displayed in this table, and you can interactively select the particular month, and it's shown in both charts. Here is the equation of the identified model, and this table shows the statistical properties of the identified model. Since the fields are green, it means that it satisfies measurement and verification requirements, and you can see that R square is not good enough for that, and it's due to the wrong model. So let's go back to the 4-parameter model, and yeah, the R square is immediately much better. We do have our monthly model. What we can do next? We can focus on weekly data and get more precise results. And we can go further and we can focus on daily data. But in this case, there are two, let's say, clouds of points. Or here, it's more obvious that one of these clouds is related to weekends, while the other one to workdays. We have an option for that. So if you have daily data from the building that has different regime over the weekends, you can select daily with weekend setback, and there are two models, one for workdays, one for weekends. But in case of workdays, the model is not good enough. Instead of manually tuning the model, we can just select the workdays and say, okay, do complete auto setup for me. And this function employs machine learning for evaluation of hundreds of combinations of models, and it provides the best combination for particular data set. In this case, it's 3-parametric cooling, and you can see all the parameters, and also of parameters of all other possible combinations. So yeah, even visually this model is more suitable for this for this data set. Now we can save the model, and that's it. The only limitation of the free version is that you can save just one model, not more. In the commercial versions, you can save 5 or 20 or 100 or 500 models in your SkySpark server. And here in the administration, we can see the model we just identified and saved. As mentioned, in the free license, there is just only one model available. What you can do is you can generate a prediction point. It will generate a point with history function that will provide the prediction. So you can use this point as a normal point within the SkySpark. So you can use it in Historian, or you can use it in your own applications and views in order to use this prediction easily. You can also go to model versus measured view here, and you pick up the model, you pick up the time span, and you can compare measurement and prediction. Let's jump to the baseline period. So the same period that was used for identification. And this is very similar chart to the one that we have seen in the model identification. So nothing surprising here. As expected, the total difference is 0, because this is the requirement from for the model statistical properties. So this is satisfied. But let's go to the next year, and yeah, we can again see the COVID story here. So this is the building from the Czech Republic, and at the beginning of the year, the measurement and prediction was almost the same, as seen also on this cumulative difference. But from the mid-March, there were some lockdowns in the Czech Republic, and immediately it was reflected in the drop in the energy consumption. And till the end of the year, we got cumulative savings like 38 megawatt hours of the electrical energy. So this is one of the ways how you can easily see the results from the comparison of the model and the prediction. You can get a free version of Energy Twin Interactive. Just go to et.mervis.info and send us a request using this form, and we will provide you a time-limited license of Energy Twin Interactive. This time-limited version will be valid for 1 month after the SkyPosium. So log in there and just send us a request. In the last section of my presentation, I would focus on Energy Twin extensions and customization. Both Energy Twin extensions do provide the open API, so you can interact with the models, you can get the prediction easily. It's shown in this screenshot on the left side that you can just use ET model predict in order to get the prediction and integrate it into your application. We do also provide some third-party integrations. I can show integration to SCADA system. Here is the SCADA system, and the prediction from the Energy Twin model is integrated using this open API, and user can easily interact with that in their own environment. We do also provide some tailored-made application solutions based on machine learning and artificial intelligence. Just a few examples here. For example, we recently made some validation of photovoltaic production using solar irradiance data. This is the figure on the right side of the screen. We do also take into account external inputs such as production data from a factory. We did evaluation of COVID-19 impact, not just on the small set of these shopping malls I have shown, but also on the bigger portfolio, where there was some post-processing of these results using clustering. And Energy Twin is also used, for example, for water consumption analysis and water leak detection. And this is the end of my presentation. Please do not hesitate to contact us on our landing page and request for Energy Twin Interactive and try it by yourself. And thank you very much for your attention. Goodbye.